Line of best fit. Why do we estimate a line of best fit for a scatter plot? So when data is collected, the points don't always create a straight line, but we want to make an approximate of the linear relationship. We want to try to see, is there some kind of pattern here we can derive from this? I'll give you some examples of what this might look like. So you don't have to actually draw this one, but just take a look at some examples. So this is age, right, from 4 to 12, and the height in centimeters. And you can see here as someone gets older, their height typically becomes higher as well. But it's not a perfect straight line. It's kind of all over the place. You see some outliers here, some things that are kind of away from the line. But most of them kind of stick close to this here. Here's another example before we put the line in. So the weight in pounds of some ground shipping, right, mailing something, costs in dollars. As something increases in weight, it's going to cost more and more money to ship it. And it tends to be in a linear pattern here, right? You can see this all creating a straight line, like the notes we had from yesterday. Here's another one. Again, this is the age of a tree, how old a tree is, and how many boards you can get from it when they cut it down, how many boards of wood they can get. And you can see as the age gets older, there's more and more boards you can cut from it. Not all of them are going to be perfect, right? Some are going to be really old and you get a whole bunch from it. Others are going to be, not that old and you still get a lot from it. It all depends on the growth. How much growth did it get? How big is it? And you can see over here, this is like a real life linear equation, tells you how quickly it's growing and where it started from. So a line of best fit, it's a line that is very close to most, okay, just most of the data points. Okay, it doesn't have to be touch all of them, but it has to be close to all of them. All right, so let's take a look. Year since 2000 and average cost of something. Okay, so this would be the year 2000, 2001, 2, 3, 2004, 2005, so on and so forth. And these are the different costs of some product. Okay, $2.60, $2.80, and so on and so forth. All right, so what I did here is I went ahead and created my graph. And you notice here that I kind of created this ongoing part. I have data all the way up to 2009. And this is the information that I plotted. I want to bring to your attention over here that I crunched up the graph over here on this side to show you that, look, these numbers keep going down, but the only ones that we're interested in start around 2.6 and above. So I'm just going to kind of zoom up to the top. That's what this little line means. All right, so if I take a look at this, I'm looking at these blue dots here. What I want to do is I want to create a line, best fit line here. So I want to try to create, and for now, I'm just going to kind of pick this one as the starting point here. And I want to try to draw a line that goes through all of this. So I can kind of see that I'm going to draw a line that maybe goes through, I don't know, something like this. Right? You can see that this line, and I keep going on with the line just to show you, this line here crosses through maybe a couple of the points. Doesn't touch all the points, but it's pretty close to all the points. Okay? So that's our first step there after we graph it. We want to just draw a line that's close to all of them. Now, just by drawing this, I can now estimate if this pattern continues. I can see it's a linear pattern. It looks like it's a positive association, right? As the years goes on, the price of this product continues to rise. Yeah, there were some years that the price went down, but then it went back up, and went down, and then back up. But overall, it looks like it's a positive association. The reason we do this is I can now take a look at, I can estimate, well, in 2010, although we don't have the data, I can go straight up on 2010 and give an estimate of how much I think this might be. So I think it might be, 3.3. 2011, I can go up to the line and go across. I think it's about 3.35 or something. 2012, it's going to be close to $3.40. 2013, it's going to be a little bit above that. And these are just going to be estimates. We know that the points might be off a little bit, but it's going to be close to those. And so that's what we use best fit lines for, to predict the future. Okay, here's another example. Use information from the scatter plot to make an inference about the data. All right, so you're going to take a moment to draw the scatter plot. These are years since 1999. So this would be 2000, 2001, and so on and so forth. And this is cell phone subscribers in millions. So in 1999 is over here. We don't know yet, but in 2000 there was a little over 100 million. 2001 there was about 125 million. 2002 there was a little bit less. It kind of stayed stagnant, maybe a little bit more, 126. 2004, so on and so forth. You can see that they're not all perfect straight line, right? We're going to have some variations, but they all pretty much create a positive association and they're linear. So what inferences can we make? Well, what I can do now is, number one, I can choose 2 points in the line. Okay, I want to choose 2 points that actually touch the line if possible. It makes my life a lot easier. So I decided to choose this point here and this point over here. Okay. Next, I'm going to estimate those points, those coordinates. I'm going to estimate this coordinate to be 1 and 110. I don't know exactly, but I'm going to say that's about that. And I'm going to estimate this one to be 7 and 230. So 1 year after 1999, which is 2000, there was about 110 million. 7 years after 1999, which is 2006, there would be 230 million. Okay, that's where those data points come from. I want to then find the slope of those points. Okay, so I find the slope. I say, look, from 230 to 110 is 120, and from 7 to 1 is 6. If I divide, I get 20. What does that mean? Well, this means that the slope is about 20, and it means that the number of cell phone subscribers increased about 20 million per year. 20 million more people subscribed each and every year as it went on. And then the next thing I'm going to do, the last thing I'm going to do is go backwards a little bit. So I already know like the slope here, y equals 20x, right? Every year it increases by 20. What I want to know is where it all started from. So I go back over here and I take a look right there. And I say, what do I think that number could be? And I'm going to estimate it's pretty close to 100. I'm going to say about 95. What that tells me is that in 1999, I think that about 95 million people had cell phone subscriptions. And then from there, increased about 20 million every single year. And so that's our last part. It just says, hey, the line seems to start at 95. So this means that in 1999, that's how many subscribers there would be, 95 million. As I mentioned before, that would be the equation of that line. So you try. Okay, scatter plot shows the graduation rate. This is the last one. I know this video is long, but it's one of our last ones. This is the graduation rate of U.S. high school students since 1998. Okay, this is the graduation rate. These are the years. What's the possible slope of the best fit line? So take a moment, try it out. All right, so what I'm going to do is I'm going to kind of maybe pick, I don't know, it looks kind of to me like these might be the best 2 points to go through. And that kind of gets everybody close to that. So that means this point here, I'm going to choose that as 160. And this point over here, I'm guessing that's going to be 870. All right. So if I estimate those 2 points, what's the slope? Well, I go 70 minus 60 over 8 minus 1. That's 10 over 7, which as a decimal, if you want to know what that is, 10 divided by 7 is approximately 1.4. Okay, or 10 sevenths. What does the slope mean? That means that 1.4% high school students rate increased each year. So that just means more and more people were graduating every year, about 1.4% every year. What's the y-intercept? Okay, so let's take a look. I'd say, I don't know, 59. So 59% would be the y-intercept. What does that mean? That means in 1998, about 59% of the high school students graduated. Which is not a very good rate, by the way. And what's the equation? All right, so my final equation would be y equals, you could leave it as a fraction, 10/7 x plus 59, or you could change it to a decimal if you prefer, 1.4x plus 59. All right, and that's it for today. Sorry the video is so long, but there was a lot of information for you there.